Hello, I'm Seema and welcome to part 8 of the chapter Periodic Classification of Elements. In this video, I'm going to tell you about the octet rule and we'll study the octet rule looking at the periodic table. This is the sequence in which the orbitals fill up, and I have already told you how the electronic configuration is related to the entire periodic table and how the periodic table is actually made on the basis of this electronic configuration of elements. I would now want you to observe the periodic table closely and notice that whenever a shell behaves as the outermost shell, it can have only 8 electrons. We have learned that the first shell has a capacity of 2 electrons, the second shell has a capacity of 8 electrons, the third 18, the fourth 32, and so on. On the basis of its having, the first shell has only s orbitals, so it should have only 2 electrons. Therefore, the first period, since these periods are actually the shells, the first period should have only 2 elements because it has only 2 electrons. The next shell, that is the second shell, has 2 and p orbitals. Therefore, the second shell should have, there are 3 p orbitals and 1 s orbital. So, if this is behaving as the outermost shell, then it should have 2 electrons means 2 elements and 6 electrons, therefore 8 elements. And let me just go by sequence here. In the first shell, that is the first period of the periodic table, we observe that it has a capacity of 2 electrons and the first period actually has only 2 elements. Right? Now, notice the second period should have 2s and 2p. Therefore, it should have 6 plus 2, that is 8 elements, since it has 8 electrons. And we observe that lithium, beryllium are the ones where the electrons go to the s orbitals, and the next 6 are in the 2p orbitals. Therefore, we have 6 elements here, and the second period has 6 plus 2, that is 8 elements. Makes sense till now. Now, the third shell should have s, p and d orbitals. So, we would expect this third period to have 2 plus 6, that is 8, 8 plus 10, because there are 5 d orbitals and each one has 2 electrons, so there should be 10 electrons in the d orbitals. So 10 plus 6 plus 2, it should have 18 elements. The third period should have 18 elements, but it has only 8 elements. Do you notice? Why does it have only 8 elements? Because when 3s fills up and then 3p fills up, the next electron does not go to 3d. Rather, according to this energy sequence, after 3p, it is the fourth shell, the s orbital of the fourth shell, that starts filling up. Therefore, now after 3p, the next electron goes to the fourth shell. So fourth shell now starts behaving as the outermost shell. The third shell is no longer the outermost shell. So we find that although the third period we expected to have 18 electrons, it has only 18 elements, it has only 8 elements. And we found that if the third shell was behaving as the outermost shell, it could not have more than 8 electrons. Because the moment it had the ninth electron did not move from 3p to 3d, rather it moved to the next shell, that is the 4s orbital. Now notice, come to the fourth period. After the 4s orbitals, you would expect 4p to fill up, but no, it's not 4p which fills up. According to energy, it is now 3d that fills up. Right? So 3d, if 4s is the outermost shell, the outermost shell is also called the ultimate shell. And the shell which is before the ultimate shell is known as the penultimate shell. So we find that after the 2 electrons go to 4s, the 3d fills up. So the 3d elements from 21 to 30, where 3d fills up, are the transition elements. The d orbitals are being filled up. But these d orbitals are not of the fourth shell. They are of the third shell actually, although they are filling up after 2 electrons. So in these elements, the outermost shell is not the third shell, is the fourth shell. So after the filling up of these 10 electrons, of the 3d, the next 6 electrons go to 4p. So the next 6 electrons go to 4p, which is here. So we have 2 plus 6, that is 8 electrons in the 4th shell when it is behaving as the outermost shell. Although we have 10 elements here, but these 10 elements, the electrons are not being filled up in the ultimate shell. In these, the electrons that are being filled up are actually in the penultimate shell. So do you observe this? Now after krypton, which is the filling up of the 4p, after filling up of 4p, the next electron goes to the 5th shell, and therefore that marks the beginning of the next period. Now the outermost shell is not the 4th shell, it is the 5th shell. And now we have to see how many electrons can come in the 5th shell if the 5th shell is behaving as the outermost shell. So we find that the first 2 electrons go to 5s, but after 5s, it is again not the ultimate, but the 4d orbitals of the penultimate shell which are being filled up. So that makes the second transition series, where 10 elements, 10 electrons are going into the 4d orbitals. But the 4d orbital is not the outermost shell. So we will not count it as the outermost shell. So now after these 10 electrons go to the previous shell, the next 6 electrons go into 5p. And that completes the number 8 here. Do you see? Now after 2 electrons go to 5s, the next 6 electrons, the next 10 electrons go to 4d, and then the next 6 electrons go to 5p. And after 5p is completed, the next electron moves on to 6s, which means that although the 5th shell had a capacity of 2 plus 3 plus 5 plus 7, so many orbitals, and multiply this 7 plus 5 is 12, 12, 13, 14, 15, 16. 16 twos are 32. The 5th shell actually has a capacity of 32 electrons. But when it is behaving as the outermost shell, it could have only filled up 5s and 5p because it had to fill up 4d before it, according to the energy sequence. So when 5th shell is behaving as the outermost shell, although it has a capacity of 32 electrons, it can have only 8 electrons in its outermost shell. Now, after that comes the 6s orbitals, and when the 6s orbitals fill up the 6th shell, the 2 electrons go to the 6s orbital. Now the next 14 electrons, instead of going to the penultimate shell, they go to the f-orbitals of the inner penultimate shell. Inner penultimate, ultimate, the one before it is known as penultimate, and the one even before that is known as the inner penultimate shell. So the electrons after 6s move to the f-orbitals of the inner penultimate shell. And these 14 electrons which go the inner penultimate shell, they start from lanthanum to yttrium. And then lutetium is what should come here. And here, after yttrium, it is the 5d orbitals, the 10 electrons would go in 5d, while we are now talking of the 6th shell, which is behaving as the outermost shell. So these 14 electrons and these 10 electrons are not of the outermost shell. Although they are filling up now, but this shell is not the outermost shell. These shells are not the outermost shell. The 6s shell is the outermost shell. So in the 6s shell, actually, only 2 electrons went, and then 14 plus 10 went to the other shells. And the next 6 electrons came to 6p and brought the number from 2 up to 8. So the octet, as they call it, the octet was completed, and once the outermost shell has 8 electrons, the next electron always goes to the next shell. So the octet rule was made on the basis of this. Do you see here? Let us come to the 7th period also. In the 7th period now, the first 2 electrons go to 7s, but after 7s, again the inner penultimate shell, f orbitals of the inner penultimate shell, 5f get filled up first to form the actinide series. Then you have 10 electrons in the 6d orbitals which form these are the 6d orbitals being filled up, but they are along, since the electrons are being filled up after this, we put these later here, but this is not the outermost shell, it actually belongs to the shell before it. So that is why they are kept separately, and the outermost shell after francium radium, the next electrons that will go would be in 7p, and these are the 6 electrons that go in the 7p, 6 elements here. So you have 8 electrons in the outermost shell. When the 7th shell is behaving as the outermost shell, you can have only 8 electrons in the outermost shell. Now, this was known as the octet rule, that we notice that whenever a shell behaves as the outermost shell in an atom, it cannot have more than 8 electrons. The only exception to the octet rule is the duplet. That is, when you have only one shell, that is the first shell, then the first shell has a maximum capacity of only 2 electrons, so it's not possible to acquire an octet in that case, because it has only one s orbital, and an s orbital can have only 2 electrons. So this is the only exception to the octet rule, that as long as it has only one shell, or it has 1 or 2 electrons in the next shell which can be lost to acquire the configuration of the previous shell, which I'll come to later. But except for that, when an atom has only one shell or wants to acquire that one shell, at all other times, when a shell is behaving as the outermost shell, it can never have more than 8 electrons in the outermost shell. And this is known as the octet rule. And a lot of chemical behavior is determined by this rule, because every element is in a race and is trying to acquire that octet. So this was relating octet rule to the periodic table, and I hope this will help you in your understanding of the periodic table further. Thank you for watching, and please like the video, subscribe to my channel, and ask your friends to see it too. Bye-bye.